Missing something. I don't know. It's no. There's a coding error, but I don't know. Button state. Scroll down a little bit. Oh wait. So const.
Oh.
Yeah. Try now. All right, so we upload it. Let's see if it's reading the values. So go to serial monitor. After, yeah, so now press the button. Try to press it. Like keep it pressed a little bit. It's not changing for some reason, so probably you have one circuit problem, but so 0 volts, 5 volts, ground. So let's see. Okay, so the 2 is reading. Something probably. Wait. Probably some circuit. It's not changing the state. Hopefully everything is connected properly, but this looks good at first glance. Oh wait, actually no.
No?
No, what? This is the other way. I think it's like this.
Oh, I didn't know there was a...
Yeah, I think. Try like that. Let's see if it... All right, guys, so explaining what's going on in the code. So remember that for all the Arduino sketches, on the top, we're going to define all the variables that we're going to use, both those that are going to change and those that are going to be constant. So for C++ notation, we have here a new keyword argument, which is const, which is basically for us to know and for future developers that might get the same code base to keep developing upon it. So you're saying that bottom pin is never going to change, and that's actually what's going to happen. It's never going to change. And then we want to write or create a new variable, which is going to hold an integer again, which is the button state. So this variable is going to change depending on the state of the button that we're going to read using the digital read. So that's on top of the sketch, always the variables. Then our second most important part is the void setup. Again, this is the first thing that it runs in our robot. Make sure that everything is correctly set up, because you might have the best logic ever in the void loop, but if you don't have everything set up correctly in the void setup, we are kind of, it might be messed up. So, and in the void setup here, as you saw in the previous workshop, so you're not only going to set up the pin mode. So remember that you use pin mode to tell the Arduino which pins we're going to be using. So in this case, we're going to be using bottom pin, which takes 2. So we are in the hardware, you see that we connected pin 2, the whole number 2 here. And then we're saying, OK, instead of output, use it as input. So you're telling Arduino in this line, OK, read data from pin number 2 in short. And then another thing you need to set up if you're using serial communication. So here is the serial.begin. And again, this part is very important if you're going to be debugging it with the serial monitor. And you're saying here dot begin, and here is the number, which is a parameter. That's called the baud rate, and that's, you're telling the Arduino at what frequency you want to listen the physical port, which is our serial monitor in this case, or serial communication. And the third part and the most important thing is the logic of a robot, which, remember, always in the void loop. And here you're doing all the business logic. Everything that you want the robot to perform, you write it here. You're saying, and remember, the void loop, and that's why it's called a void loop. It's always running. It's endless, and you cannot stop it, basically, unless there's a coding mistake. So here, you're using the variable that we define on top of it. Remember, it's always the best practice to define the variables on top of it. And then we are assigning that button state with the digital read value, which is our built-in function that Arduino provides. And in this case is the digital read, and you're saying, okay, what pin do you want to read data from? So in this case, from pin number 2, and this is going to read the state of the button. If it's pressed, with a pull-down resistor, it's going to be 1 because the gate is closed, the energy flows. And if it's a pull-up resistor, it's going to be literally the opposite. And here, what you're saying is, use the serial. Again, this is our main class that we are using from Arduino. And we are calling the method println, which is basically similar to the system.out.println from Java or the print from Python. And you're printing to the monitor the value of the button. And that's a way of debugging the application in general, and now we see it as with this particular project. So moving on with the next project, actually we're gonna introduce the new component. In this case, we don't have to change the push button, but in this case we're gonna add one LED. Just skip the fact that these are two different diagrams, but they should be in the same breadboard and using the same Arduino, just all in one. So for the LED, remember, you need to pick up one 220 ohms resistor, and for the button you don't need to change anything. Just as in the previous workshop, just wire the LED part, and we're gonna switch on and switch on an LED based on the input provided by the digital read from the button. And remember from the last workshop that the LED had one longer leg, and that's the positive pole. So make sure you connect the pin, the digital pin, to the longer leg, so the largest one. fix. Let's do one more minute to finish with the LED, and then we jump to the code. So if you guys go to the Explorer Hub, you will also find in the code section the code that you need. That's actually the exercise that we're going to do. So the same way that we did with the previous workshop, we're going to fill in the blanks, the to-do parts, and then we see the result. See you guys. Have a good day. Good day.
then we'll calm those down a little bit. So is it a choice kind of thing? Or it's always on. Variables we're creating and stuff. In general, if I'm honest, I'm guessing most of the size constraints are joystick, yeah. That's yeah, gaming joystick. So you can press it and throw that, right? So writing code for this is very normal. Yeah, because that's like a gaming thing, like a Z-axis thing, like a gyroscope something. Move it around, right? So, yeah. So one, this is enormous, and secondly, the code is very normal. So normally you can use flag. Another thing is this. Yeah. This is distance sensor, ultrasound. Yeah, I used that a little bit before. Yeah. So again, most of the time you're going to use a library like this. And that is what has a lot of memory can control. Yeah. If you want, you can make it yourself. I guess if you're adding a lot of libraries, then it makes sense to like go to the library and take notes on code that you're not going to use.
Do we have any solution yet?
This is 7
Not yet?
Yeah.
No. I guess no.
Touchscreen. Surprisingly, touchscreens are relatively easy, which is interesting. Oh, really? Like, sorry, not touchscreen, but a touch detector. Yeah. I guess like making OS stuff. Yeah, before little microcontrollers sound below well. Make my own OS. Make my own game console. Or I just get a Linux stuff. Stop with Raspberry Pi. Just good enough. You know? Alright, so can you look up this, the multicolor LED? Or becoming a Linux programmer for the first time. What do you want to look up? Just the wiring specific.
Any volunteer to code along with me? The solution? Anybody? Any volunteer?
Sure.
Yeah, okay. You tell me the solution.
If the button state is equal to hot,
Okay. What?
then digital write,
Is it all right?
LED pin, hot.
Hi.
Else, digital write, LED pin, low.
Like this?
I want digital and like, yeah. Yeah.
All right. Thank you. So try that solution and test if it works. So now when you press the LED, while you keep it pressed, it should turn on.
The worst part is finding out what's wrong. I think any system that gets big gets really complex.
Are those LEDs turning on?
Electricity is more.
No, yes,
Yeah.
not yet.
Okay, that's interesting. Alongside of
Here, is it working?
I'm like checking if I did something wrong.
Did you upload the code to the Arduino? Like clicking the arrow button?
It's giving me a compilation error.
What does it say? Expect the initializer before end. Oh, you're missing the semicolon here. And here equals LED. Oh, wait. LED pin. What pin is it?
usually alongside of like,
2.
it's not, this is never gonna.
Actually, no. It's. Wait. Let me see. Because I have it wrong. Guys, what pin are you using for the LED?
2.
2? Okay. Oh, that's not for the button?
No, we set the LED to 2 and then button to like, I think 12.
Was it? Okay. So the LED to 12? Actually connect the LED to 3 and the button to 2. If that makes sense. Let me see. So LED 3. So change the LED, the red wire to 3 from here. So you don't need to change, yeah, just there. Instead of reading in 12, just put it 3. The button is 2.
Object drawing program is very useful
So completion error before end.
because you can encapsulate all
Again.
of the sensor into the class. It's much bigger than all of those that do not need all of them.
Try to upload it again. Try to upload it again to see if, I don't know why it's, where? Let's see now. Press the button. Oh. Again. No, it's not working for some reason. Check the serial monitor. Click here. 0. And if you click it, oh, so it's not. Why it's making false contact? Wow, it's disconnecting when you click it. That's strange. Has it ever read 1 before? Oh yes?
It did. And when I put the LED and
Oh, you know why?
right.
Because remember that you are using the same columns as the button. So you should put the LED circuit apart from those columns. Try to put it somewhere here.
Okay.
Because it might be collecting the energy with... So yeah, like there, for example. Yeah, it's right there. Now it should work. How is it going here?
For us, it's actually doing the opposite.
It's doing the.
It's like it's on the whole time.
No way.
It's on it.
When you. So
We're trying to maybe switch it. We're not sure.
the serial monitor, what does it show?
Yeah, it's fine. Like right now, okay, when you click on it, it's 1, and you take it off, it's
So
0.
high, and then set it to high, right?
Yeah, we had that before.
And that's not working?
I mean, it is working, but it's like it's on the whole time. But when we press on it, it turns off. It should be the opposite.
Did you upload it?
Yeah. We just wanted to try something different.
Oh wow. So it's the other way around.
Yeah.
But with that code as well?
Yeah. Like we didn't change anything. I just changed it up. It's the exact same.
You know why? The same happened to her. So for example, here you're using the same columns. Like you are probably mixing circuits. Like here it's using energy from the same button circuit. You should set the LED circuit apart.
Oh, okay.
Let's say you can do it somewhere. Because remember that the energy flows column-wise.
Yeah.
So here, I think you're using the column of the button with the same LEDs.
So you're saying to move this
To move the LEDs, probably. The LED to the right, probably.
the LED, not the actual button?
You don't need to move the button. You can just move the LED. It's easier.
Okay.
I mean, if the button was working, it's better to just move the LED.
Okay. And would I move the resistor as well?
Yeah, everything. So everything related to the LED.
So it is one with the. So then it is this bit and this bit.
Let me know when you get it. How's it going here?
I got to work. I'm working on the third one.
It's working? Okay, great.
I'm only working on the third one.
The code? Okay. So any questions with this project? We can move on with the next one, which is actually a modification. So in this case, instead of just turning on the LED while it's pressed, you want to just change a permanent state. So when it's pressed once, Like let's say the light switch, you want to switch on the LED, and when the same way you press it again, it turns off. So again, I uploaded the Project 3 code in the Explorer Hub, so and then we do it together. Now you can see that on top of it you have two variables that are going to change. So you're going to use the button state, which is the same one as before, but now you have LED state. That's where the logic comes for this permanent state, basically, of the light, of the LED in this case. And try to use the serial monitor when you have any doubts to see what the data is. And then once you understand what data you have, then you implement the solution. That's a really good practice to do. Yes. Okay. It's not turning on. I think because the wire is not in the same column as the leg, the black one.
Like it's supposed to be the same color as the LED?
It is. It should. There. Let's see if that makes much. It's not. For some reason it's not really. So okay, so you're using pin 13. Try to use another pin like 3 and change it in the code, because 13 is the internal LED. Let's see now. Oh. yet. Let me see one thing. Okay, this might be the reason. Yeah, because the longer leg should connect the positive side. Yeah. Try to click it. No, you don't need to compile it. Yeah, but the energy is low. Is it 220 ohms resistor? It's a 220. 20 or 220? There are two. Which one? Oh, actually, you need the 220. That's why it might be like less bright than expected. Yeah, it's 220. Yeah, that one. Try just changing this resistor. So now after that, you can start this code. So now instead of just pressing it and turning on while it is pressed, you just want to change it like a switch, light switch. When you click it, you permanently switch on. Yeah. Here, how's it going? Is it working though? You got it incorrectly? Why? Why do you think it's...
I don't remember. I forgot to take a picture. I think
It's not turning on. Changes to one this? Yeah, so this is... Oh, actually... Why stays at one?
Oh, it changes. It just stays for a while.
It stays for a while, why though? This is...
Maybe
Trying to see... This looks good. Two. Two. This is 1, 0. It's changing, but it shouldn't change too much. Stays. For some reason it's staying, and then ground. So this is there you go. But I don't know why it has a sort of a delay. Like it doesn't change too much the... See. Oh, this is a new code, right? The old one.
I put on the comment because we're trying to put it permanently.
Uh-huh. I don't know why there is a delay, like it should be immediate. But like open the previous code, the old one. This is the old one? No.
This is the
That one, okay, so did you do it right? So wait, we're gonna... So I have this, have that, so there is some part of the circuit that is not working. Positive. You sure this is the 10K resistor? Let's see. 15K. Is it? No, it's not. That might be the
So
problem.
that's the issue.
Yeah, that might be the issue because there's less energy than I expected. Same place. Try now. Hopefully. Oh wait. No way. Reminder. This is so weird. No, it's not even changing. 3. So that is fine. Ground. The problem is the LED is fine. The problem is the why the- why? Oh, I see why. I think. Wait, I don't want to get electric. So it was in the same column as the button. Like, I know it's microscopic. Wait, let's see now. Wait, it reads 1. This is weird. I mean, the wiring is let's see, maybe it's not the way I told you. It's like this. My fault. I don't think so though. Wait. No, you
It
can.
looks the same to me.
Look. No, I mean, it should be like this. I guess it was. So here. It's kind of, you know, the choose. Let's see, I don't know why it's not. Maybe some circuit stuff. No, it's not. Oh, wait. What? Still uploading. What do you mean not connected? It stays on. Wait. Input.
Oh, it's 0.
Now it's 0, yeah, but it's like, and then it's like laggy. It's some circuit that is messed up. I don't know what. Wait. Okay, I don't know why there's a delay. Oh, look. It's... something is wrong with this. I don't know what.
Maybe I put one too deep.
Too deep.
I don't know.
No, you didn't. Well, actually, in this state, you could still do it, this project. So you need to tweak the logic. So you need to use this. So when it's high, instead of just setting high, you just need to change the variable, and then read, or do, for example, digital write, and then it would be here the LED state. So you just need to make the logic to change the LED state, and here you pass it the LED state. Try it.
So I just made it so independent pieces. Just actually stay on or off depending on it's just whether or not.
Okay, so it's working.
Yeah, but I did it a little differently than what you suggested because I think if you were doing it when you're doing it, it will oscillate whenever you're holding the button.
Okay.
What I did was I actually used split state, so that way I set it to split state to what it was before the beginning, and then I just check the time and see if it's not that way when I press the button, it switches.
Great.
And I just use Martin's logic so that I don't have to.
All right. Yeah. It's a good one. Great.
And then I also put statements right here.
Great. For
Because
debugging. Great.
and that's just all of these.
Great. Yeah. Actually, your implementation is really good. But what I did it on purpose is for that, because I wanted you guys to think what happens if you hold it. Like it should like
Awesome.
didn't stop.
Yeah.
Yeah, didn't stop blinking.
I know. That's what I figured.
No. Yeah. But it's good. It's good. Like for a permanent solution, it's really good.
I wanted to actually make it.
Yeah. It's really good, man. Congrats. Well done.
Hey, I grabbed it at your science.
Huh?
I should know this stuff.
Yeah, man. You know a lot. You're good. You're in the good way.
It's already on. Then you turn it off. Okay. And then another also. Or do you do a one check? Because what if it's off? And like what if we don't press on it and then it's off?
Mm-hmm.
So then what do we do in that case? To turn it off?
Uh-huh. How's it going here? Good.
Still working on it.
Working on it?
Yeah.
You need help?
A little bit.
What? What's going on?
Trying to figure out the logic with
Uh-huh.
pressing the button. So if the button state is
Hi.
right and the
LED state.
state is false,
Uh-huh.
then when it presses, it should turn the LED state true.
Wait,
Huh?
you have a syntax problem.
Where?
LED state equals true. That's a conditional. It's just, you need to put just one equal. No. That's gonna change your life. Look, because this is just saying if let's state is true in the air. Wait, it's not working? And probably something else.
Completely forgot.
LED, if LED equals true, this is the right LED, then high. Else. Oh, maybe reduce the delay to 75. You need to tweak it a little bit. Just hold it on. Wait, you have, look the wire, the white wire.
Oh. Oh, it's the white and the ground. Oh my god. Oh my god. I'm actually trolling. Actually trolling.
Give it a try now. Yes. Is it permanent? No.
Yeah, well,
Yeah.
yeah.
Okay, so now you need to tweak the delay because that might be like repeated readings or something.
So let's say
Yeah, it looks good. Progress? Yeah, great. Let me know if you need help. And thank you for coming. I hope to see you next project, in the actually next workshop. We're going to do the final project, and probably it's going to be a fun workshop.